I am happy to see all of you here. So my name is Andrey Fleyta. I am from the Postgres Professional. We are the mostly Russian company. Because I have just a few moments here right now, I advertise you the next session we will have tomorrow, same time at the Neptune room. We will provide more information about reliability. So my presentation is non-technical, of course. It's totally marketing. Don't worry, you should believe in everything I will say you. So just trust, nothing special. Anyway, if you will have any questions about the things I will talk about or things I will not talk about, just come to our booth. The right choice for you is to turn right if you're exiting from this room. So on the right, you can receive any answer you have. So we, as a Postgres professional, working mostly with big enterprise customers. So we have just a little, let's say, touch on the public cloud. So mostly we have the customer with very big installations, or the customers with dozens of thousands of instances of Postgres. So in their own private clouds infrastructure. So all these customers care about the reliability, security, scalability, and performance. So everything, as always, stay the same. So what we see right now, we see a lot of customers from the last year with dozens of terabytes of data. In some cases, this is hundreds of terabytes of data. We see more and more CPU cores inside the servers. Memory, of course, is not the case right now, and we see more and more connections in the infrastructure. And of course, these customers we work in these are trained by Oracle, by Microsoft, not this version of Microsoft we have here, but the traditional one with MS SQL. And we wanted to have very simple to use things, and they wanted to have everything done in one button click or something like that. That's the reason why we create our own fork, which combines a lot of more features on top of the open source version. As I said, all these features are oriented to implement big installation inside the enterprise. I will not go through all of them, so if you want, we can cover it later or discuss on our booth, but most of them are oriented to proceed hundreds of terabytes, billions of transactions, and to make it more or less reliable. So for reliability, we have a number of features. Of course, we have replication, which exists in vanilla version. And, but because customers are very, let's say, unhappy to do any complex installation, we have built-in high availability feature. So we implemented cluster inside the Postgres, so you don't need to configure something else, you don't need to add extra software, you don't need to monitor it, and so on, so on, so on. So there is a lot of stuff around this, and possibly I will touch it later. We have a multi-master technology which provides and oriented mostly for the installations that needs minimum downtime in case of a failure. So this feature has many drawbacks behind, but we can proceed, consistently work with the data in case of the failure of single master server. And in either single seconds or part of the second or milliseconds, continue to proceed data on the other masters we have up and running. Because we have a databases, I mean OLTP databases with hundreds of terabytes of data, so we can't proceed it on a single server right now. And that's the reason why we implemented the sharding mechanism. And using the sharding, we split database across dozens of servers. Our biggest current installation is 300 terabytes and something like 26 or maybe 28, I don't remember exact number, 20 plus servers running it, and 1 billion of transactions per week. So that's cluster proceed money, as I remember. So they store information about the payments, and we have these things done to make it, let's say, single instance operating this function. Because we implemented, a lot of stuff, which is, I forget to remove. Because we implemented built-in high availability, so we have ability to switch over between nodes, and this not require any extra software. We have another problem like switching between how the application itself will switch between master and slave, and how to make it simpler, or maybe in some cases invisible to the application. In this reason, we implemented a special piece of software like a proxy stuff, which can reconnect the application to appropriate master leader server to either to the replica if it required. And because we had this piece of software which tightly integrated into the Postgres backends, so this software knows everything about the Postgres itself. So we know how it loaded, how much memory used, is it up and running or overloaded, and all this stuff. So we can implement some extra things which simplify life of enterprises. So we implemented the puller function, we implemented the cache. Because as I said, we know everything about the changing of the data inside the Postgres itself, so we can effectively invalidate this cache in case of the changing of the data, not through this proxy stuff, but through the other applications not working through the proxy. And because some of our customers was scared about the Redis changes, so we implemented other protocols, and Redis was the first protocol we implemented on this cache. Of course, customers like big enterprises are very, very care about the security. So we have a lot of stuff done there. Of course, it's encryption as Bruce wrote maybe some times ago in his post, there is dozens of implementations of TDE on top of the Postgres. So this looks like that we will implement it, should implement it somehow in vanilla version 2. So possibly it will comes there, but right now it's always some extra function which done already by many companies, and of course we have it. We have different role-based optimizations, we have different stuff around the analysis, and so on and so on. So if you want, we can provide more details on this, but I don't have right now a lot of time, so I will skip it. I'm in details. The same stuff about the performance. So everybody care about it, and everybody wanted to have it immediately right now without any special things to do. So the most effective stuff is compression. So of course you can compress the data using the operating system functions or file system functions. We implemented inside the Postgres, so we implemented page level compression, which reduce I/O and improve the performance in case if the disk is a bottleneck for your performance. And this feature helps a lot, especially if you have such intensive I/O and a lot of data to read-write. There is a lot of optimization in the indexing, planning, caching, and all this stuff, and we try move all this feature to the vanilla version, to be honest. So all this stuff more or less earlier or later will be in vanilla, so we don't store it for our own say usage only. So all these things going into vanilla, but not so fast as we expected in some cases. New stuff we implemented was using the machine learning algorithms and other stuff to help the planner and optimizer to use the appropriate plan. So ACO, which is adaptive query optimization, using the machine learning mechanism to understand how often the planner select a wrong plan. We understand which plan will be better and provide the, let's say, hints, not the hints it's in reality, but we provide this information to planner for the next request coming. Adaptive query execution is another thing. They change the way how we can replan the request during the processing phase. So if you have a request which proceed long, use a lot of memory, or other triggers are coming up, so we can replan it and adopt it to the, let's say, changed situation, or let's say to improve mistakes in the planning. So a lot of other things, and if you want, we can go in depth in, in each particular point. As I said, the customer are frustrated about the performance in some cases, and because we did all this sharding stuff, I mean distributed system, we start thinking about a way how to improve the performance of it. So we right now working on a combined hardware and software solution with very high-speed interconnect between and specific synchronization mechanism between the nodes. So this simplify the way how we can proceed data in a parallel across the dozens of servers. So we can do changes in the database across the different servers with a minimum interaction between them using this synchronization. So it's dramatically helped to Shardman, sharding version of the Postgres we provide, and it helped a lot to the traditional replication mechanism. So we're using RDMA technology, we're using some other techniques to speed up the replication too. So it's again improved the traditional way of clustering too. The next stuff, how much time I have? Okay, maybe a few minutes. Okay, the next thing we're doing is HTAP support. Again, because it's an enterprise, so they don't want to care about all this data warehousing, all this way how the lake house should look like, how to move data, how to use them. So we implemented the support of the S3 storage behind the Postgres and working the Parquet Iceberg formats on the S3. And of course, there is no this stuff on the picture, but we have extra software which copies the data from the Postgres to this S3, so we can using ILM techniques, so we can move old versions of the data to archive, which is S3 for example, and then provide to the application the single point of access to any data. Modern one, old one, doesn't matter. So you don't need to change the application for that. And of course, we are the best company in the world. So if somebody will told you something else, so don't worry, just exit on the right.